Okay, so folks, the last we spoke, we were talking about this vertex form, and we're going to continue applying transformations of quadratic relations through using this vertex form of quadratics. So for this lesson, you're definitely going to need this note, and if you're unable to copy it down for whatever reason today, you will definitely be able to get your hands on a completed version of it. Um, and I would also suggest having a highlighter, definitely a highlighter, and definitely a pencil and eraser. Okay, so let's get going. In this equation, we have here y equals ax minus h squared, and that squared is super important to have there, plus k. And we learned all about what a does in 5.1, right? And in 5.2, we really focused in on h and k. We did a Desmos exploration. We did some homework on that stuff. And now what we're going to do today is kind of put all of that together. Now the constants a, h, and k have all these different types of meanings, and I believe this is something we also talked about the other day. So let's start off this vertex form. We have a. Now remember, we often separate the plus and minus from the a, but let's just look at a. A indicates whether there's a vertical stretch or maybe there's some sort of vertical compression. Now it's a stretch when a is greater than 1, and it's a compression when a is between 0 and 1. So basically when it's a decimal starting with 0 point, or maybe it's a proper fraction. It's certainly a compression. Now, a indicates a reflection in the x-axis if it is negative. So when you see a negative there, that's its own little thing. It's like, yeah, this is a reflection in the x-axis because we're always comparing everything to y equals x squared, and y equals x squared is already facing up. So the moment that a value turns negative, we say, oh, it's now facing down, which in terms of transformations, that's just a reflection. Let's look at h. Now inside of these brackets is always a little bit tricky, so be very, very careful. H represents this horizontal shift either left or right. So when H is, H is bigger than 0, of course, it's going to the right. And when H is less than 0, it's going to the left. Now, when you're going right, it'll look like it's negative. It'll say like x minus 2, and that should indicate 2 to the right, because we know a positive 2 went in there for H. And if it says x plus 1, that's a shift to the left, because that's a negative 1 that went in there. And when you subtract negative 1, you get a plus 1 in those brackets. So be very, very cautious of the horizontal shifts because they could be tricky. And lastly here, we have the vertical shifts. And vertical shifts are really nice because, they kind of just make the most sense. If k is positive, it's going up. And if k is negative, it's going down. So that's pretty much that. Now, what I've also have here is I have this box here in gold, and the reason why I chose, well, it's orange, but I tried to make it gold. And the reason why I wanted it to be gold is because this is the best information that you pull out everything. A, H, and K mean absolutely everything to us. H and K are literally the values of x and y of the vertex, and that a value is what we're going to use to multiply the multiples of the step pattern. So when it comes to graphing quadratics, vertex form is exactly what we want because we can pull out all the information and graph it. And of course, the x value of the vertex is in fact the axis of symmetry, which means our h value represents our equation of the axis of symmetry. So you can see a lot of overlap here from all the quadratics work we've done, and now we're going to, I guess, focus in on applying transformations. So here we go. We have a chart here. It says complete the chart. The first equation is y equals 2x squared plus 5. So they're asking us whether there's a stretch compression, a reflection, a vertical or horizontal translation. What's the vertex and what's the equation of the axis of symmetry? So first, given here, notice we have a value of 2, and we have a k value of 5. Now it does look a little weird there because typically we're used to seeing it in vertex form. So maybe I can write this in true vertex form for you. Like if it were really written in vertex form, it would look something like this. squared plus 5. Now, the reason why they don't have it written like that, like x minus 0 squared, is because x minus 0 is 0, and then squared is just x squared. So they have it always simplified for us. So if this might help you understand the transformations a bit better, it's there right for you. So first, a value of 0, which means there's some sort of stretch happening. Is there a reflection? No, there's absolutely not a reflection. Is there a horizontal or vertical translation? Well, if you look, h is 0, so there's no horizontal, and k is positive 5, which means going up 5. In that case, the vertex would be 0, comma, positive 5. I always put a v beside the vertex. It's not really necessary, but I like to do it. You don't have to do it, but you can if you like. And given the vertex, you know that the equation of the axis of symmetry comes from this x value of the vertex, or the h value, and it's x equals 0. Next one here, we have y equals 4x plus 2 squared minus 3. Now, looking at the a value, is there a stretch? Yeah, a value is 4, so it's certainly a stretch. Is there a reflection? No, there's not, because it's not negative. Is there a horizontal or vertical translation? Well, yes, there is. There is a horizontal, and now it says x plus 2. You might be deceived here. You might be thinking to the right because it says plus 2, but really there's a negative 2 in there. And that's what makes it look like a plus 2. So that what that negative 2 is saying to us is it went left 2, and the minus 3 at the end here is saying it went down 3. So I think we just say left and down. Given that, our vertex would be negative 2, negative 3. And last but not least, the axis of symmetry is just x equals negative 2. Again, it's just the x value of the vertex. Okay, example number 2. You're going to have to really mind, forgive me with my penmanship here because I am using a mouse and it's not always that great, but here we are. Write the equation of the parabola that matches each description. So again, we're always comparing to y equals x squared in every single one of these examples. We always do that for transformations. It says the graph of y equals x squared is, and this is where I'm going to pull out my highlighter, is reflected in the x-axis. Okay, so that tells us something. Then translated 8 units right. Okay, so if it was first reflected in the x-axis, what would happen to y equals x squared? It would turn into y equals negative x squared. And then translated 8 units right. Well, that's probably you're thinking our h value. So that'll look something like y equals negative x to the right. So x minus positive 8, close the bracket, squared. All right, again, you're really going to have to forgive me on my penmanship here. Okay, then part B, y equals x squared, all right, pulling up my highlighter here, is compressed by a factor of 1/4, translated 2 units left, and translated 4 units up. So first, y equals x squared is compressed by a factor of 1/4. So that means our a value is 1/4. 1/4 x squared. Okay? Then it was translated 2 units left. Now left indicates the horizontal, and of course at some point k is going to represent the vertical translation. So you could go, for the next part here, we're thinking, okay, well, 2 units left. So y equals 1/4 bracket x minus that negative 2, which means it's going to read in the brackets as plus 2 squared. Okay? And then lastly, this translation of 4 units up, y equals, and here we go, 1/4 x plus 2 squared, and 4 units up, so plus 4. Okay, now at this point, I want to note some things. First and foremost, please, please, please ensure that the squared is there. If the squared is not there, it's not even quadratic anymore, so just be cautious of that. It needs to be there. Another thing here, you're probably wondering why I've written 3 of them, right? We got 1, 2, 3 of them, when typically, I think there's many of you out there thinking to yourself, can't we just go to here? And the answer is yes, you certainly can just go to the last one that I have highlighted in green, but just for the sake of, this is our first time kind of seeing this, let's just take it translation by translation, right? One thing at a time. Okay, in this last one, we have the graph of y equals x squared, and I'm going to pull up my highlighter here, is reflected in the x-axis, stretched by a factor of 2, translated 5 units right, and then 8 units up. Okay, so let's go ahead and just go for this last one, just because writing with the mouse is not pretty, and I will definitely run out of room. So we'll start. Now, reflected in the x-axis and stretched by a factor of 2 is relating to our a value. 5 units right is relating to our h value, and 8 units up is referring to our k value. So it'll look something like this. Y equals negative, right, because it's reflected, 2 stretched by a factor of 2, and in the brackets we got 5 units to the right, so x minus 5, right, close the bracket, squared, please don't forget the squared, and then up 8, so plus 8. Look at that. We are pros, and maybe at this point you're not shocked by anything at all. And if that's the case, that's great, because that means you're doing really, really, really good with this. Let's move on. Example number 3, it's very much the opposite of example number 2. In this case, they're asking us to describe in words the transformations that were applied to the graph of y equals x squared to obtain, and I noticed my spelling error with a P, obtain each of the following. So, if we had y equals x squared, and we used this technique before, y equals x squared. So notice that we have the 2 that is not highlighted, the 3 that's not highlighted, and this 4 that's not highlighted. So that kind of indicates some things that happened to the parabola. So I personally work from left to right. So the first thing I'm going to look at is this a value of 2, right? So the a value of 2, well, actually, maybe we should think about the reflection. Like, there's no reflection here at all. It's certainly just positive. But this a value of 2 indicates that there is a vertical stretch by a factor of 2. So you can put like number 1. The first transformation is, the vertical stretch by a factor of 2. That's the first thing that happened to y equals x squared. Now we have this minus 3 in the brackets, and just be careful, because I know it looks like it says negative 3, but really we know that there's a positive 3 put in there, and a positive 3 as an h value indicates that it went to the right 3 units. So we say horizontal shift 3 units right, or maybe you might say horizontal shift right 3 units. And last but not least, this plus 4 at the very end here, it's really nice because that's our k value. It's a vertical transformation. And what that means is this is a vertical shift 4 units up. And that's that. That is that. A very, very important skill to kind of develop. How about this next one here? Example B. What would happen to y equals x squared? Let's have a look. Now, again, this is another example where I'll often say we got to separate that negative from the coefficient here, this a value. So the negative on its own will get its own transformation. Like just the negative here. Just the negative will indicate that there was a vertical reflection. So that's the first thing we're going to write. We'll say reflection in the x-axis. That's just the negative. Now, the 0.5. The 0.5 is it's not a stretch, it's actually a compression. So we'll say vertical compression by a factor of 0.5. Inside of the brackets, so that was the negative there, negative 0.5. Inside of the brackets it says plus 5. Be careful, because really we know that that's a negative 5 in there. And what that means is that this is a horizontal shift 5 units to the left. And lastly, we have negative 7 for k, and negative 7 for k means down 7. So vertical shift down 7 units. Okay, take a moment to write that down in your notes. Using this type of terminology, again, I'm going to pause and kind of just reflect here. Using this type of terminology, vertical stretch by a factor of 2, horizontal shift 3 units to the right, like all of that it's all necessary. We can't just say 3 right or 4 up. We can't just say it like that. We have to indicate whether it's horizontal, vertical, or and whatnot. Okay, example number 4, match the graph to the equation. Now, you might have your own strategy here, in which case that is great. Personally, I like to look at 2 pieces of information. The first piece of information that, you know what, this piece of information alone will probably get us through this entire problem is to just indicate the vertex out of each of these equations. So in A, let's go ahead and look at the vertex. The vertex for A is positive 4, right? I know it says x minus 4, but it's positive 4, comma 5. That's the vertex for A. The vertex for B is negative 1, comma negative 5. The vertex for C looks to be, I'm going to put a V here, negative 6, and then there's nothing here, so we just assume that it's 0. There's nothing for K, so it's 0. Let me bump this down a little bit here. For equation D, the vertex is going to be negative 8, comma 1. And last but not least, the vertex is 7, comma, positive 7, comma, positive 3. Now, that is the one piece of information that, you know what, it will get you through this problem. But I know in the homework, they try to trick you a little bit. They'll give you the same vertex for some of these questions. So don't just get used to looking at the vertex. Also determine whether the parabola opens up or down. That is another useful piece of information. So in order to do that, we look at the A value. So this A value looks to be negative 1. So what that means for us is that this parabola opens up. Down. In part B, the A value is positive 5. So this one opens up. There you go. Now, in C, there's no A value. That might be a little bit misleading. But remember, if there's nothing really there for A, that's just a 1 outside of the bracket. So that's just opening up. In part D, this is negative 2. So that A value is saying it opens down. And lastly, in equation E, it's an A value of positive 3. So this opens up. And again, opening up or down might not be too good in this example, but it'll be super helpful in the homework. So for equation A, I'm going to look for the parabola that has a vertex of 4, 5. 4, 5, right here. So this is parabola A. B, the vertex is negative 1, negative 5. Negative 1, negative 5, this is B. And also, notice how narrow this parabola is, right? See how super narrow that is? That comes from the A value being such a big number, like 5. So that means it's really narrow. We're looking for the vertex negative 6, 0 for part C. Negative 6, 0, it's right here. That's C. D, we're looking for opening down and negative 8, positive 1. Negative 8, positive 1, there that is. So that'll be D. And we know the last one is going to be the last one here. But just for the sake of consistency, let's look at 7, 3. Okay, that's confirmed. It's a little bit more narrow because that A value is 3. So this is parabola E. Okay, great. Give you a moment. So in order from left to right, we got D, C, B, A, and E. Okay, the very last slide here. Hang on with me. The other day, I know we graphed parabolas in this vertex form, but these ones are a little bit beefed up because they have values for all 3 variables A, H, and K. So in order to graph, for example, this first one, the first thing we're going to have to pull out of this parabola is the vertex. And the vertex will act as our starting point. So in this case, our vertex is positive 6, comma, negative 9. So if you want right now on your graph, you can find positive 6 and then negative 9, and you can put a point right there because that's where that graph starts. Now, how are we going to get more coordinates? Well, we're going to really look at that A value and use our step pattern. So as far as we know right now, the original step pattern is 1A, 3A, 5A, dot, dot, dot. And after that, that's Let's make that a little bit bigger. That's kind of, as many as you need. Sometimes the graph will only hold the first two steps, and that's okay. But after 3, I know that's quite a bit. Now our a value here looks like it is positive 3. So we're going to say, okay, a is positive 3. And we can sub that in. The step pattern, SP is step pattern, equals 1 times 3, 3 times 3, and 5 times 3. We're just replacing that a value with 3. And when we simplify this, the step pattern is 3, 9, 15. Right? So from this vertex over here, we're going to go over 1. Let me grab a new color. Over 1, up 3. 1, 2, 3. Put a point. Over from this point, over another one, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then from this point, we would go over 1 and up 15, but our graph doesn't allow for that. So we'll now go to the left side of the parabola. Over 1, up 3, and over another one, and up 9. Now, what I'm doing here really quickly is just going over 1, matching with the original over here, and then going over another one and just matching up with the second point we plotted. And from here, we can graph our parabola, and this is going to be really tricky here with the mouse. Let's go ahead and that's brutal. Let's go ahead and do our best. There you go. So close, but yeah, I think you get the idea. Okay. Now the next one here, we have y equals negative 4, x plus 5 squared plus 6. The first thing we do is we pull out the vertex, and in this case the vertex is negative 5, comma, positive 6. And we can go ahead and plot that if we like. Negative 5, positive 6, and we plot the point right there. That's our vertex. Now, in order to get more points, we will use this step pattern, and that is 1a, 3a, 5a, 7a, 9a, 11, and it goes on forever, as we know. Our a value in this case is negative 4. So 1 times negative 4, 3 times negative 4, 5 times negative 4, and so on, and so on, and so on. And then we just multiply those. So we'll get negative 4, negative 12, negative 20. Okay, so this is our step pattern. From this coordinate here, we're going to go over 1 and down 4. 1, 2, 3, 4. Now the reason why we're going down, well, first of all, you might notice that it should be opening down by the original a value, but also our step pattern reminds us that this is opening down. So over 1, down 4. From here, we go over 1 and down 12. So we're at positive 2. We're probably going down to negative 10 right down there. Okay, that's 12. And now we can repeat for the left side of the parabola. We go over 1, down 4. Over another one, down 12. And there we have it. Now we can just connect the dots with a nice smooth curve. There we have it. We put on these arrows as end behaviors. And what we could also do here is label our parabolas. So this one is y equals negative 4 bracket x plus 5 squared. Hey, squared plus 6. And this one over here was y equals 3 bracket x minus 6 squared minus 9. Okay. And folks, that is it. I believe you may need some graph paper, in which case there is graph paper in the classroom, or maybe you can use the little sticky notes if we have them. But this is pretty much it. We have some homework assigned here on page 269, numbers 1 to 3, 6, 8, and 11. But for number 11, it just says in vertex form. I think the question says something about something else, but we're just looking at here vertex form. It's like state the equation perhaps in vertex form. And that's it. That's all we got. Enjoy the rest of your day, everyone. We'll see you next time.